In this section, we're going to be learning a process of dividing polynomials called synthetic division, and then we'll be using the synthetic division to study what's called the remainder theorem and the factor theorem. Okay, here's the first example that we're going to look at with dividing polynomials using synthetic division. Okay, of course here you're being asked to divide by x minus 2. So if you were to solve this, of course like x minus 2 equals 0, you get positive 2. So when you're setting up the synthetic division, you're going to put a positive 2 out front, and then you'll have a row of numbers here which will come from your coefficients and your constant. So we would have positive 5, negative 6, positive 3, positive 11. Alright, your first step is to bring this first number, in this case the 5, bring it straight down. Then you start by multiplying the 2 times the 5, which is 10. Now add the negative 6 and 10, so we get positive 4. 2 times 4 is 8. Add, you get 11. 2 times 11 will give us 22. Add, and we get 33. Now I know a lot of you who remember doing synthetic division in the past, and there are some things that you have learned that require that you get a remainder of 0. That's when you're doing the factor theorem, the remainder theorem that or mainly factor theorem that I mentioned a while ago. Here you're just simply dividing, so it does not have to divide evenly. This one didn't. Now, I want you to be able to take what you have and put it back as a polynomial, like with x to whatever power. This problem was a third power, so once you do the division, of course this being to the first power, the numbers you have here across the bottom will now represent a polynomial that's to the second degree. So this represents a polynomial, like I said, to the second degree. So you would start out with 5x squared plus 4x plus 11. Just go with descending order. Now with your remainder, you have to put plus your remainder over your divisor. Your divisor is just simply what you were dividing for. So this is your answer. Okay. Right, here's another one. Of course, this one is presented to you in the fraction form. So setting this one up, again, if you were to set this equal to 0 and solve it, you get negative 1. So negative 1 is going to be out front. Now, when you arrange the numbers here, it has to be in descending order. So that's going to be largest power down to your constant. And if you have any terms missing in your problem, you do have to fill in zeros. So like for this one, this actually would be my first term if I put it in descending order, and its coefficient's negative 1. Since I don't have a fourth power, I have to put a 0. Next is my third power, its coefficient's 2. I'm missing my second power. I'm missing my first power, but I do have my constant of positive 6. Okay, bring the first number straight down. So start by multiplying. So negative 1 times negative 1 is positive 1. Add, you get 1. Negative 1 times 1 is negative 1. Add, you get 1. Negative 1 times 1 is negative 1. Add, you get negative 1. Negative 1 times negative 1 is positive 1. Add, you get 1. Negative 1 times 1 is negative 1. Add, you get 5. Okay, now your answer, remember, is always going to be 1 degree less. The degree of this polynomial is a 5th degree, so this would represent a 4th degree. So your answer would be negative 1x to the 4th plus 1x cubed plus 1x squared minus 1x plus 1, and then plus your remainder divided by your divisor. So there's your answer. So that's how you do synthetic division.